And here you see, let's say, just an example of their effectiveness. Here is the time history response of the top story of a six-story frame structures without any dampers and with, let's say, interstory placement. Okay, you see a big reduction is achieved with this kind of devices. Here you see some real application. I designed it, let's say, 15 years ago. It was an industrial building near to Bologna. And here is the layout of the plan with the indication of their position. And here you see pictures. They can have also an architectural, let's say, appearance that can be highlighted or improved. Their connection can be very easy. It's just, let's say, a steel connection as usual that you typically use for bracing system, metallic bracing system. Well, in the scientific, but still the issue of developing simple analytical methods in order to size and locate them was open. And my research activity was actually developed to this, to provide the practitioners with simple methods. Okay, so just a theoretical base. I would like to give you just some ideas that maybe you can find in my papers, or you can think about them. You know that Rayleigh damping in structural dynamics sees the damping matrix C as made up of a mass proportional component and a stiffness proportional component. And they are characterized by different behavior of the damping ratio with respect to the frequency of the structure, of the frequencies of the structures. I would like to show you that the two components of the Rayleigh damping matrix are physically separated and independently implementable with manufactured viscous dampers. So that actually we can have a physical mass proportional damping system on one side, which sees the dampers working with absolute story velocity because they connect the story with the ground, or better, they can connect the story with an infinitely stiff element like a rigid concrete core or a bracing system. Okay, and on the other side, we do have stiffness proportional damping system, which sees dampers that work with relative interstory velocities. And so, well, these two mass proportion and stiffness proportion damping system actually are characterized by completely different properties. And I don't want to enter into the mathematical detail. I do not have the time. But if we assume that the dampers are just equal, but simply placed in order to connect the story to the ground or within an interstory placement, well, it is easy to show that under some, let's say, uniform assumption in terms of stiffness and masses, it is possible to demonstrate that the damping ratio of the interstory stiffness proportional damping placement is far smaller than the damping ratio provided by the mass proportional damping system. So that actually, and you can find here, let's say, the analytical demonstration in this paper. So actually, it is really convenient to put the dampers to connect the story to the ground, to the story to a fixed point, rigid concrete core. Okay, so this was the idea that drove me into the study of let's say, mass proportional damping system, which are much more effective in reducing the structural response. You see in the black line the undamped response, in the red line the response of a typical interstory damper system, and with blue you see the mass proportional damping system, which is far more effective. Okay, here you see their effectiveness not only in terms of displacement but also in terms of velocity, acceleration, and interstory drift angles. Okay, I also developed, let's say, some years in the past to apply genetically genetic algorithm, let's say damper placement, but the result I found was really not useful. I mean, I concluded that it was not worthy at all to, let's say, to devote time in optimization of damper system, but it was better to go straight to the mass proportional damping system, as I told you, because for at least for 4 reasons. Different dampers require higher manufacturing costs, danger of numerically optimizing only few response parameters and forgetting overall behavior. And always in seismic engineering, you should always look for uniformity and regularity in earthquake engineering. Also, there is a limited efficiency due to the effect from non-proportional complex damping that may arise. So my proposal is to look for this kind of damper placement. Direct implementation this way, which however can be subjected to some buckling issues that somehow can be avoided with mega braces or other solution, technological solution, or this one, which is quietly adopted already in Italy. And here you can see an application in an hospital building in Bologna, in which 2 blocks of the system were equipped with external stiff reinforced concrete towers to which the dampers were connected, and for the sake of non-invasive seismic strengthening from outside of the existing structure. Here you see also, well, the details of the design and some rendering of them. Actually, I took advantage of different proportion between the damping ratio to find a formula, which is this one, that allow us to quickly dimension the viscous dampers. And here the formula is written for mass proportional damping system, here for interstory or stiffness proportional damping system. Okay. And now I have to conclude because time is running up. Just to tell you that in 2010, I developed this, let's say, 5-step procedure in which the design philosophy is to limit the structural damages under severe earthquake. The structural elements should remain in the elastic phase, which means that we know that materials are ductile, and let's keep the ductility resources of columns and beams an additional property to withstand the very severe and unexpected earthquake. Let's say the 5-step procedure is based on this 2nd step formulation, which is the one I showed you a minute ago, and you find it in this paper. And later in 2018, I have improved it with a challenge to provide a direct, fully analytical, let's say, procedure that, let's say, cancel any kind of finite element modeling and substituted it with, let's say, some estimation made in an analytical way that are provided by, let's say, this formulation. You find all details in this paper of 2018. So to conclude, I have highlighted the mass proportional damping effectiveness with respect to the traditional stiffness proportional damping or interstory placement. And I have just told you, of course, I didn't have demonstrated you today, but I have just told you that there is the possibility of applying a direct, fully analytical procedure in which, on the basis of very few parameters like the period of vibration of the structure, the total weight of the building, and the damping ratio we want to obtain, let's say, we can quickly size the dampers. Okay, so thank you very much for your kind attention. Thank you. Thank you.
Thank you very much, Stefano. I don't know if Stefano, I got a question from the auditorium by waiting.
Yes, please.
Did you use for this very kind method the spectrum or the acceleration? And the analysis is fully nonlinear, right?
The design has to be conducted in with the spectrum to be easy. So this is a preliminary sizing. So the size, the value of the damping coefficient C of the fluid viscous dampers is obtained on the basis of a response spectrum. But in any case, as I wrote here, a numerical verification of the final behavior of the system by means of nonlinear time history analysis is recommended. So this is for preliminary design, and you can further calibrate it by means of time history analysis. But let me say that the objective, when applied to new structure, should be to keep the structural element within the linear elastic phase. So theoretically speaking, we don't need nonlinear time history analysis because we don't want to that the structural elements, let's say, are damaged when we put the dampers. Actually, putting the dampers has the main objective of keeping safe the columns and the beams.
Okay, thank you very much.
Thank you very much. I'm sorry for the technical problem. We've been lucky to see the conclusions. Okay.
I'm still sharing. If you want, I can, let's say, draw the conclusion again. No problem for me. Tell me.
Okay, ladies and gentlemen, we have amendment to the program. Our next speaker is Dr. Rida Gulshan Kavas. I would like to thank you, Dr. Silvestri, for your presentation, and sorry for the technical problem that we have.
No problem. Thank you.
Sure. وحسب ما سمعت دكتور منتظر, would you please introduce yourself?
From different countries. Most of them most of the close friends from me were from Syria. I realized that Syrian guys are very gentlemen, polite, and clever. So it was my desire to travel someday into Damascus, to Germany, and see the people and meet them and spend some days with them. Few days before, a friend of mine in Iran said that there is a conference, international conference in Damascus, and would you like to travel there? And I said, yes, of course, my pleasure. And here I am. As I said, I studied my master and PhD in Germany in construction, structural base. Today, I present one of my scientific works, especially for young researchers and students. It is a kind of probabilistic reinforcement, but I try to explain it very simple and easy, make it easy and I try to make a bridge to your mind, and maybe in future we can make some cooperation together. Yes, please.
Please,
Next.
Dr. Montazer, you have 15 minutes.
Technical problems exist everywhere. So please, next slide. Next. I apologize from professor and my colleagues. I have to explain shortly some technical words. Nowadays, everybody have heard about reliability, the ability of a system or component to do its function in a period of time and a specified condition. I will explain also basic variables in my research. In this presentation, the physical and geometrical parameters which involve in a model are basic variables. We make physical as a probabilistic formulation. Please, next slide. And when I was a student also in university, and I continue to learn how we can set the partial factors or safety factors. To do this, we need to do some probabilistic approaches. Previously, scientists used global safety factors. For example, they test the property of material or soil or something, and they say, okay, to be sure that it will work, we divide the resistance by 3, by 2, or something more. That was a global safety factor. Nowadays, we divided this global safety factor to different factors, which is called partial factors. We multiply loads by some factors more than 1 and reduce the resistance by factors less than 1. To reach these factors exactly, we have to do some probabilistic calculations. We make a model, as I will introduce you in next slide, and we measure the probability of failure. Could you please give me some water? Is it possible? Thank you. Okay, I call here in my presentation the resistance part by R and the action part here by S. Normally resistance are greater than action. But what happened when resistance is smaller than action? The failure occur. We measure these failures by probabilistic manner and calculate the reliability of a designed structure. This method, which I present in next slides, can be applied in all of the engineering methods. Today, I presented only for masonry structures, a shear wall, because masonry structures are very important in sustainable construction nowadays, and shear wall is the main structural part of a masonry. Okay, the next slide. This is a figure of a shear wall, which is a major part of a masonry structure, unreinforced masonry structure. Many methods or models or formulation exist to calculate the capacity of a shear wall. Different scientists from Germany, from other parts of the world has worked on this works. Here are a glossary or a result of some of their works. A shear wall can be collapsed by tipping failure of masonry around its corner, or can collapse by flexural failure, like figure B, or friction failure, or a sliding, like the last slide. Please, next slide. Could you please go to next slide? Yes. And there are some other failure modes, like tensile failure, cracking of units, overturning of single unit, compression failure of masonry, shear compression failure of masonry, and so on. This figure is a general or very simplified figure of behavior of shear wall under pressure and shear in the same time. Friction failure, tensile failure, and compression. There are the main failure modes for a shear wall. We model this deterministic formulation in a probabilistic approach, full probabilistic approach, and try to find the probability of failure and then reliability. Okay, next. In this case, I used only some available test results to calibrate my model, to find the uncertainty of the model, and to build a probabilistic function. This graph shows the different behavior of each failure modes. For example, the green shows flexural bending failure modes from without load to until maximum load, and different failure modes in deterministic manner. This is what an engineer work with it. But we go one level higher and work like a scientist to find how to set this formula for a safe and benefit cost design. Okay, next. Just I introduce you the case that we examined in a laboratory. We used some results from Maser, which has done in Europe some years before. I chose 15 samples. The results were clear. The walls were made with mortar in bed joints, normal mortar type. The observed failure mode was only diagonal tension. Wall thickness was 30 millimeter, 30 centimeter. Wall dimension was 1.5 to 1 meter. Unit dimensions and overall overlap of blacks was 12 centimeter on. The slender of this shear wall was 1.5. Okay.
Dr. Muntazir, you have 5 minutes.
Okay.
Please, okay.
I'm almost done. This is the result which we gained from experiment, the first column. The result comes from laboratory, and the other columns are the results that we calculate from formula. Now we want to compare how this formula work with reality and how is the level of safety, or how we can set the safety partial factors. To do this, first we find minimum capacity of this wall by our formula, which are not exact and are simplified, however. The deviation is presented in last column. Capacity, which is recorded in experiment, diversity by calculated in formula. Normally, as you can see, normally the capacity which is observed in laboratory is higher than what we calculate with mathematical formula, 1.2, 1.2, and so on. We use the last numbers to calibrate the formula, or to better say, to make an uncertainty function, probabilistic uncertainty function. Okay, please go next slide. Here is a statistic calculation of the results of last table. Mean value is around 1.14. Standard deviation is 0.7, and variation coefficient about 6.5%. I use these statistical numbers to build an uncertainty model, and I use it in first line calculation. We use the capacity minus actions, resistance minus action. When G, or the function, is negative, that means failures occurs. And of course, we always expect that G is not negative, is positive. That means normally resistance should be greater than actions. We try this model. Instead of each function, we use our basic variables in a probabilistic values. For example, for masonry compressive strength, Fk, I used here in this calculation log normal function. The mean value standard deviation comes from test. Unit tensile strength also comes from test, but in a probabilistic manner. And sometimes also we use deterministic values. That means they are fixed, they are exact, like coefficient of friction. We don't use any probabilistic function for that. And we continue, we make our model with these basic variables, and then we start to run this model. The number of failures are very low. Few failures will occur. We will see what happens. Could you please go to next slide? Okay. This figure shows how every single parameter works, like normal, log normal, which introduce parameters from test. And this is one presentation of output of resistance. And the last picture shows limit states, section between actions in green parts and resistance. In this presentation, I do the trails for more than 1 million times. And you see most of the results, that means resistance, are greater than actions, but few of them in that rectangular in green flash are in weak side.
Please,
That means failure occurs.
Time is over. Please wrap up very quickly.
Yes, okay. Next slide. Yes. the lines shows the deterministic calculation that normally engineers do, and the points shows what we have done in probabilistic manner. Okay, next slide. So from this model, and there is something, okay, go. Next. And next. Okay. From the this model, we count the number of failures. The number of failures divided to total number of trails. It shows the probability of failure, few out of million. This number is very small, and the work with it is a little bit difficult. So sometimes we use inverse Gaussian distribution, minus inverse. It gives us a number that we can compare it with codes. Index should be for a shear wall. I took from Eurocode this table. For example, for we expected 3.2 for average reliability index. In this case, we observed that the reliability index is much higher than what we expect, sometimes more than 4 even, related to the load. Just next slide. Actually, I've done this simple calculation shows you how we can reach the reliability index of any construction model with full probabilistic.
Okay, although we don't have time, actually, I allow one question. If anybody have a comment or question for Dr. Montazeh.
Actually, I'm available today and tomorrow, hopefully. So if the students need to talk about this, I can take part in.
Okay, Dr. Montazeh, thank you very much.
You're
Thank you.
welcome.
Our next speaker is Dr. Youssef Diab. كمان المتحدث القادم الأستاذ الدكتور يوسف دياب، وأيضا عبر زوم. نأمل أن تكون المشاكل الفنية قد تم حلها. الدكتور يوسف دياب هو أستاذ التخطيط والهندسة المستدامة الحضرية في جامعة جوستاف آيفل في فرنسا، وهو مجال أبحاث مخصص لإدارة البيئة، وهو متخصص في استراتيجيات المناعة الحضرية. مناعة هي الريزيلينس، urban resilience، أحيانا بترجموها الصمود والتكيف مع المناعة. وللدكتور يوسف دياب أكثر من 150 ورقة بحثية وتقارير علمية في مجال الاستدامة الحضرية وإدارة الخدمات الحضرية، ويقوم أيضا بتحرير سلسلة من الكتب حول المدن المستدامة. عنوان البرزنتيشن: المدن القادرة على الصمود أو المناعة، مبادئ البنى التحتية ودورها. So our next speaker is Dr. Youssef Diab, who is a professor of urban sustainable planning and engineering in the Université de Gustave-Eiffel in France. His field of research is dedicated to infrastructure management and decision-making tools in urban contexts. He specialized in urban resilience and climate change strategies. Dr. Youssef Diab is the author of more than 150 reviewed papers, communication, and reports in the field of urban sustainability and urban services management. He is also editing a series of books on sustainable cities. The title of his presentation is Resilient Cities, Principles and Role of Infrastructures. Dr. Diab, the floor is yours. And if you can finish the presentation in 15 minutes, we will be able to have a small discussion and the Q&A session afterwards. Thank you very much.
Thank you, Dr. Mualla. It's a pleasure to meet my colleagues in Damascus, and next time, hopefully, I'll be with you in the next conference in the fall semester. Just for a few words about my university, you are as many of the colleagues did their research in France. Our university is the former one de Marne-la-Vallée. Now it changed our name. It's to Gustave Eiffel University, and we are a national university because we have campuses all around France, and we are like University of the United States dedicated to one topic. It's delegated to sustainability and urban planning, urban design, and development of territories. So it is an interdisciplinary approach of what our territories need. And if you want more information about this university created in 2020, I'll be very happy to give you some elements. So in this presentation, I'm going to share with you some of my research done about resilience. As Dr. Mualla said, the word in Arabic, it can be something not very clear. It can be maruna, it can be sumud, can many things. But let's say about urban resilience. This example, I am showing what we are doing with NYU, with New York University, in a kind of working group called MAWAC, about how to integrate nature-based solution in the resilient cities. You see, this is the south of Manhattan, and there's a big new project, what we call a dike development in a park, and we are working all together on the integration and planning. Other example is the work we did on after the Hurricane Katrina in New Orleans, and about how to build back better the city. I select this photos because it's very relevant that the resilience is a part of the sustainability. This is a topic of this conference, and I think having resilient infrastructure is a major element for the sustainability, for the long-term sustainability. We use very often a word called build back better. Build back better is a very important concept in resilience, and the resilience by itself, it's not something that has to be considered as an end issue, but it has to be a participation in the sustainability. Another issue that we know all around the world, that catastrophes are back. So what I mean by that, my colleagues, the three presentation, and especially the two first presentation, talked about earthquake. In our approach, we are dealing with all the hazards. We deal with hazard related to earthquake, but mainly with hazard related to climate change and to the adaptation. So, for example, when we talk about New Orleans, you see the cost of damages. It's around $100 billion. The same, you can see the example about Sandy in New York, also $71 billion for reconstructions and for the establishing a good situation after the hurricane. The famous one is Fukushima. And what happened in Fukushima, that as you know, in Japan, all the design against earthquake are very high quality, but the Japanese code is designed for earthquake of magnitude 8, and this one was a magnitude of 9. So the resistance was not very easy, and also it was combined with the hurricane with a height of wave of 9 meters instead of 6 meters. So sometimes our building codes are built, and construction codes are not really considering this exceptional hazard. Exceptional hazard is very important, and we know this very well in the Middle East. So our infrastructure have to be more robust and more resilient about this. This is what is happening at this time in Japan about the reconstruction. Just So now this was some elements to give you that context. So in my research, we are working on two concepts. First one is decomputerize. That's mean, and you know that civil engineers, architect, urban planner, geographers, and specialists in ecologies, they have to work together. This is one of the major topic of my research. And then to work on complexity. I think that it's important to tell our colleagues in the universities of Syria that working on all the infrastructure together is very important, because there's interdependencies between all these elements. So what kind of hazards we are working on? We have two categories: the shocks. We know earthquake, wildfires, floods, sandstorms, etc., etc., and also working on chronic stresses. Chronic stresses is very important because it's generating a lot of continuing problem in city. For example, we know that the air quality is very related to the public health issues. For example, also the poverty is very important. So when we are talking about urban resilience, we are considering all these hazards. We are decomputerizing all these elements, and we are involved in international networks, especially one dedicated to resilient cities based in USA. Then, so this is what is our approach is doing, how to identify the natural hazard, then how to work on it with in the infrastructure, and also on the urban system. Urban system are for us the networks of the city, the sewage system, the water system, the road system, etc., etc. And all this have their functions, and we try to understand what will happen when they have when there's hazards. So in this research, we are working on three capacities. The first one is the resistance. This is really civil engineering, how to have very robust infrastructure that able to resist before the crisis, before the shock. Then during the shock, how to absorb this shock. And the third one, and which is very important for our countries in the Middle East, and especially our lovely Syria, is the recovery capacity. The recovery capacity, it's something has to be to have a strategy on national level, and also on local levels. And we have to mobilize a lot of tools like GIS, like risk-based approaches, etc., etc. So this research is having these three components, and the three components are always related. And as I mentioned, the interdependencies is very important. I am showing you something that we did in Paris about the interdependencies between sewage system, energy systems, water systems, and this is for sure it's based on the graph to give the city of Paris a kind of map showing if there's a flood of this intensity, what's going to happen, which area is going to be flooded. This is what you see on in blue. And we did the same project in for Dublin, in a European project, and we were able to identify with many hazards. For example, a dam burst, what is going to happen? How are we going to estimate the damages, etc. So our theoretical theory for this is integrating urban system functioning in the response. I mean, we cannot anymore allow to say the architect do the design, the civil engineer do the dimensioning and the implementation. They have to work together from the early stage of the design. And this is what we did a few years ago with the University of Damascus by developing a master called Master of Sustainable Cities to try to encourage people to work together about the sustainability in cities. So regarding our component about civil engineering, our infrastructure have to be reflective. That means we need to learn from each other, from each experiences. This is what I'm trying to doing by this part. This is second one is you have infrastructure as redundant, because you can, when one is failure, the other one will work instead of it. The inclusiveness, I think it is very important to talk about this, that all the population have to be consulted and all the areas. We cannot have infrastructure strong in some city, some area of the city, sorry, and weak in other city, in other part of the city. And this is related to work we did it with UN Habitat in Cairo about a report. You can download it on their site about informal issues in Arab cities, that we saw that inclusiveness is very important. And then the last point is to be integrated system, that we have to have a kind of design of our system in integrated way, not only a system by system, component by component. Now, the third part of my presentation is some example. This is what we are doing in Paris. In Paris, the major challenge is the floodings. So we are trying to understand what will happen in the cities, in the infrastructure during a flooding in Paris. And we have a research program now for 10 years about these issues, how to manage the city. The second one is related to the climatic adaptation, is the severe drought that is happening in Europe in many areas, especially in cities like Barcelona, Marseille, etc. So severe drought is very important. And as you know, the drought is going to generate problem in soils like shrinking, like settlement, etc. So this is another chronic risk that we are dealing with. And then we try to implement our solution. For example, you see the nature-based solutions. This is the parking we have in hospital in Paris. This is after the design by our teams and by our students, how this area, we don't have anymore the parking. We have this nature-based solution and having green space to have an adaptation strategy for the city. And also now we expanded our work, and we are working on this project about outdoor comfort, about overheating in cities. And this is some of the example of one of my projects that we are doing it in United Arab Emirates with the Executive Council of Dubai, how to implement this solution of adaptation and of resilience in the public space and specific areas. Thank you very much, and I hope that it was okay. And I respect my time. Thanks, Dr. Malla.
Thank you very much, Dr. Youssef. And thank you very much, especially for adhering to the time. So you still had 2 minutes. So I am going to open the floor for questions and discussion for our colleagues. أي سؤال؟ ماشي حلو. وضع الانشاءات تبعيتهم الامطار تبعيتهم. Questions about the UAE, you know, is how resilient Dubai is to the major, let's say, precipitation that happened last month, which took over 200 millimeter in a matter of 24 hours. Any information regarding this, Dr. Youssef?
In fact, as you know, it was not resilient at all, because what happened is that these floodings happened that the infrastructure was not adapted to such scenario on that. So unfortunately, they had a lot of damages, and the team over there in Dubai are still estimating the damages. They don't have with enough precision all these elements, but I think, as I said, that the robustness of infrastructure is related to hazard. So when you underestimate the hazard, you cannot have the adequate infrastructure. So I think in the coming years, it's going to be resilient. Last time it was not resilient, and they are going to modify it. But also there's a lot of a question of adequacy between the means and the risk. For when you don't have enough money. It's not the case of UAE. You cannot have structures that resist to everything. For example, I take the example of New Orleans. Till now, they don't have means to have a resilient city. They know if there's a flooding in 2-3 years, they are going to continue to have damages. In New York, it's not the case, because in New York, they allocate a lot of money to make the city of high level of resilience, of integrated with risk and resource. Yes.
Okay. Thank you very much. Thank you very much, Dr. Joseph Diab. It's great to have you with us in this conference. Oh, thank you very much for your work. And now we are going to move to our next speaker. العرض القادم هو من الدكتور ربيع شماس. Our next speaker is Dr. ربيع شماس. هو أستاذ مساعد senior lecturer في الهندسة الإنشائية بكلية الهندسة والتصميم والعلوم الفيزيائية في جامعة برونيل في لندن. وقبل انضمامه إلى جامعة برونيل كان محاضرا ثم أستاذا مساعدا في الهندسة من تموز 2017 إلى ديسمبر 2023. حصل على الدكتوراه في الهندسة المتقدمة من جامعة برونيل، كما حصل على شهادة البكالوريوس من جامعة دمشق، يعني من هذه الكلية، في موضوع الهندسة المدنية الهندسة الإنشائية عام 2007. عنوان العرض الذي سيقدمه هو استخدام البوليمرات المسلحة بالألياف البازلتية في البنية التحتية للخرسانة المسلحة. Our next speaker, Dr. Rabi' Shammas, is a senior lecturer in structural engineering, College of Engineering Design and Physical Sciences at Brunel University, London, UK. Before joining Brunel, he was lecturer and then senior lecturer in structural engineering at London South Bank University. He received his PhD degree in civil engineering from Brunel University as well, and also the master degree. His BSc is from Damascus University Faculty of Civil Engineering. The title of his presentation, The Use of Basalt Fibers Reinforced Polymer in Reinforced Concrete Infrastructure. Dr. Rabi' Shammas, the floor is yours. Please, you have 15 minutes, so we can allow 5 minutes for discussion.
Thank you very much. Good morning, everyone. Can you see my screen?
Yes, Rabia, yes, it's okay. I saw it.
We can hear you, and we can see your presentation. Go ahead.
Thank you very much for the introduction, and it is my pleasure actually to talk to you again. My presentation is about the utilization of basalt fiber reinforced polymer in concrete infrastructures. So why we need to use a basalt fiber reinforced polymer? Over the last 7 years, I've been investigating on the utilization of basalt fibers as a sustainable construction material. So what is the problem with the corrosion reinforcement? In reinforced concrete, the corrosion will have some structural impacts, like, for example, reinforcement steel will suffer of ductility and strength reduction and loss of bonding. It will have also economical impacts. For example, repairing and maintenance cost, also corrosion, cost of corrosion protection is all will affect actually the cost. Some social impacts, for example, it can reduce the safety. It can have leading to kind of sudden failure of the corrosion reinforcement. So this is some example of the corrosion reinforcement structure, especially in aggressive environment like bridges, seawall infrastructures, etc. So all these actually a corrosion of reinforcement will have effect, economical, social, and structural impacts. Now, there are a lot of solutions to mitigate the reinforcement corrosion, but all this solution we find out is costly, and it doesn't protect 100% the reinforcement as well. It's also is not sustainable. So what is the solution? It's basically the use of basal fiber reinforced polymer. So the basal fiber reinforced polymer is a material which is actually, we bring the basalt, we melt it up into 1,500 degrees, and we put it in the nozzles, and this nozzle actually you will have a fiber. So it's very straightforward. There is no additive material can you see in glass or carbon fiber. So the other competitor, it's more energy needed, and also is not environmental friendly. Also, where you create the fiber, the basalt fiber. So you're gonna have the rovings where you're gonna have the fibers around. Now, after that, we're going to use these fibers for advantage. So what is the advantage of these fibers? Is basically the main advantage is lighter than steel, higher strength than steel. The most important things nowadays is life cycle analysis showing that the embedded carbon of basalt fiber reinforced polymer is 74% lower than steel, carbon steel, or even 88% lower than stainless steel. So it is more convenient to use it in a lot of structures because it will reduce the embedded carbon of structures. Now, what we can use it? We can use a basalt fiber reinforced polymer in different forms. We can use it as a rebars. You can use it as stirrups or links, a macro bars, shop fibers, or geotextile and mesh, which is in road infrastructure. So all these applications can be used basalt fibers. Now, how to make basalt fiber rebars? It's simple a production process and is not highly energy needed. It's simply you're gonna have a number one a roving of fibers, and then it goes to the feeding dyes, and then it goes into resin, etc. And then you're cutting process and curing. So the process is very simple and straightforward. It doesn't need a lot of energy. Even the electrical energy needed, it could be used for the renewable energy. So it's very efficient. And example of the basalt fiber reinforced polymer being used, for example, in columns, it could be in the bridge decking, it could be also in seawall infrastructure. So there's a lot of application we can use basalt fiber reinforcement. It's been used recently in US, and now they are starting to use it a lot. Basalt fibers and the carbon. The basalt fibers, it's don't have any yielding point, as you can see from figures. Also, but the problem with it, its elastic modulus is lower than the carbon steel, and the rupture strength is different. So because they have a different property from the carbon steel, therefore the structural performance will be much more different from each other. Now, it's then you have to do some and conduct some testing. But with the basalt fiber reinforced polymer, because it's a polymer material based, we need to do some durability tests. So in funded project, actually, thanks for Innovate UK, we carry on some elementary testing of this rebar, but actually this is for dowels in slabs. We test flexural shear and direct shear according to the ISO standard, and we put this dowels on rebars actually in active environment, which is alkaline environment, and also chloride environment or acid environment. And we put it in accelerated environment, accelerated testing for 7, 14, and 30 days. We can see there's a drop reduction in the strength. So this is need to be considered in design. For instance, for at 9%. So this be taken in consideration in the design. What are the available design standard? Actually, the available design standard in US, but polymer yet in the design, in their design standard. Maybe recent one, which is ACI, the American standard, adopt the basalt fibers for polymer, but the other standard, Russian, Canadian, or US bridge standard, it doesn't adopt anything yet for the basal fiber reinforced polymer because of the lack of testing and investigations. Now, Eurocode, unfortunately, Eurocode design, it doesn't adopt any fiber reinforced polymer yet. There is a provision of annex, but doesn't put anything in a basal fiber reinforced polymer yet. FIB it's give some example. It's about how to use fiber reinforced polymer. It's again, there's nothing about reinforced concrete is basically it's a crushing of the concrete, and it could crush or it could be rupture of the rebar. It depends on reinforcement ratio. Now, thanks for the Global Challenge Research Fund, we that developed in collaboration with Moroccan institutions. We propose the use of basal fiber reinforced polymer entirely in continuous structures. It's stirrups and rebar, both of them. And we did the casting continuous structure, which is structure being used a lot in seawall infrastructures or bridge engineering infrastructures. And it's entirely reinforced with basalt and the stirrups and the rebar. And we find out that it's in design standardization, what is called moment of distribution. But what we find out in our research after the conducting the whole research is we find out that yes, we can have 20% moment distributions based on our observations, which mean that we can reduce the moment over the span supports and put some of these moments over the mid-span. Now, because of basalt fiber reinforced polymer,
you have 5 minutes, please.
Yeah. Basalt fiber reinforced polymer is an innovative material. So we put these basalt fibers actually in alkali activated concrete, and we test this reinforcement. And we did some life cycle analysis, and we find out the life cycle analysis with LCA that we have a huge reduction in LCA, which is embedded carbon, from 19.84 kilogram of carbon dioxide into 5.6, which is that in two innovative material can be integrated in a structural member. We test some of the fire resistant, and we find out the basalt fiber, it's actually lose integrity at 500 degrees. So that is what it's recommend is if you wanted to use it in high temperature, you need to provide enough cover. For example, if we put 300 degrees, we find out the strength reduced by about maybe 3%. So it depends on temperature. But when it's 500 degrees, it's the fibers, it's only burned. So we cannot use it in very aggressive or high temperature infrastructures. Comparison with design, we propose a comparison design standard, actually according to Eurocode, using the principle that we know in Eurocode, and we compare actually with test data by collecting about 330 data points. We find out that our for flexural, we did that for shear and with the stirrup and without stirrups, and also we did that actually for deflection, and we find out that our design comparison with in Eurocode principle comparison with ACI give very good correlation and even better. And we proposed actually, according to the reliability analysis, a partial safety factor that can be used for designer, and this currently used by a lot of designers in the UK, this partial safety factor. And we also propose to use the basalt fibers as a stirrup, so and see the effect of basalt fibers stirrups on the capacity of the beam and shear capacity. It is an increase by about 20%, but it's not a huge increase. So what we did, we add some macro bars into these structures. By adding these macro bars, we noticed that flexural tensile strength of the concrete increased by 60%. So if we add it into concrete, with the stirrups. And without stirrups, we find out there's a huge increase in the capacity of the beam by about 80%, which is a great opportunity to use macro bars of basalt macro bars in structure to enhance the shear capacity. I will drop this actually, the shop fibers. We added shop fibers actually, and I will drop this slide so I could share it with you guys later. And further research, I would say there's a lot of further research we can look at. It is punching, shear, crack width deflections, life cycle and cost analysis we need to do, and also incorporating basalt fiber with some kind of concrete like alkali activate and Innova concrete. Finally, and there's going to be a lecture. I would like to invite you for this public lecture. I will give this lecture for a institution of structural engineer about the utilization of basalt fiber in concrete. The link is up here, so if you would like to register, the presentations are up 27, I think, of June. So I will present more details about the design, as well with some of my colleagues actually from industry. Thank you very much and for listening.
Thank you very much, Dr. Shammas. I will allow 1 or 2 questions if I have any questions or comment from the audience. Dr. Andraus.
Do you have any communication about under tension?
Did you hear the question, Dr. Shammas?
Not really. Can you repeat the question or someone can tell me the question?
I think Professor Andraus is asking if you have some elongation. I could understand what he said. If you have a plateau and your sigma epsilon curve, I think you, yeah, okay. You can keep. So
This one.
Yeah, this is for steel.
This is for carbon steel and this is for BFRB.
There will be no elongation, no ductility.
There's no ductility actually for BFRB. It's basically elastic up to failure.
Okay. Any other question?
Just to mention, I think there's a misconcept is, okay, there's no ductility, there's no failure, but with BFRB, we allow a big crack width by 0.5 millimeter, which is fine for a few of infrastructure, but still we have to allow for a limit crack width by 0.2 to 0.3. So there's a relaxation of the crack width for the basalt, so it can be used in even an aggressive environment because it cannot be corroded.
Okay, one more question.
It will not work under an earthquake.
Yes, under earthquake. There is no crucial investigation yet on using it in earthquake. However, there are some research on glass. I never did any research of BFRB. I expected that it will have an elastic behavior. So it's basically after the earthquake, because of the elasticity of the FRB will return to the original shape, like a shape memory alloy somehow. So some researchers integrate two material, which is shape memory alloy, at the same time BFR or FRB. In this case, the property of FRB and the property of shape memory alloy work together.
Question, maybe most of our colleagues.
Sorry, I can't hear the question.
Yeah, greetings, Dr. Rabia. This is Dr. Muayyad Subh. We conduct also some researches on BFRB here in our university, in our labs, and our researches were confined only in elastic elastic ranges. Did you find in your researches or labor any way to use the BRFB in plastic range, or you still search in elastic ranges?
Okay. Now, in earthquake or in a normal infrastructure under static loading?
Did you hear the question?
Yeah,
Dr.
I hear the
Shammas,
question.
Did you hear the question?
Yes.
Dr. Shammas, most colleagues here are asking about when, because most codes, design codes and seismic areas require plastic energy dissipation. This will require yielding plateau in the curve.
Yes.
So the FRB, it is linear, as you see it from the graph
Yes.
you just have on your slide. So is it possible to use reinforcement, FRB reinforcement in seismic area where as you don't have any plastic energy dissipation?
Okay, thank you very much. Okay, that is very good question. The question here is, yeah, can you hear me? Yes. My research is only around the durability of the BFRB and the static performance. It's under quasi-static analysis. Now, with regard to seismic application, I think FRB rebars reinforcement, it can be used in hybrid system. It's much better. Which I mean by hybrid system is basically BFRB and steel reinforcement, or BFRB and shape memory alloy. In this case, you will have higher, maybe high dissipation system. So FRB alone, I don't know. I didn't see any research of using only FRB reinforcement alone in shear walls, for example. But I've seen some research, they use it with other material like steel, carbon steel, and also shape memory alloy. Now, why we use FRB? For two reasons. Is firstly, because of the lower embedded carbon, which has low embedded carbon, lower than carbon C by 88%. Second opportunity is we allow for higher crack widths and anti-corrosive environment. So these are the two main applications. Now, the VFRB, so far when I work with a lot of company, they use it mainly for ground-bearing slabs or water retaining structures or seawall infrastructures where there is no fire and there is no hazard of earthquake.
Okay. Thank you, Dr. Shammas. We have to move to our next speaker. شكرا جزيلا دكتور شماس.
Thank you.
لهذا المتحدث التالي دكتور شيرين علي عبد الله الأجرودي، وهي أستاذة الهندسة البيئية بكلية الهندسة بجامعة عين شمس بمصر القاهرة، وأستاذ مساعد سابق في قسم الأشغال العامة جامعة عين شمس، وأيضا أستاذ مساعد سابق في قسم الهندسة المدنية في الجامعة البريطانية في القاهرة، وحاليا أيضا مدير مركز التميز المصري لإدارة المخلفات الصلبة جامعة عين شمس. The title of her presentation, Advancing Sustainable Waste Management in Egypt, Comprehensive Insight into Municipal Solid Waste and Biochemical Treatment. So our next speaker is Dr. Shireen Ali Abdullah Al-Ajroudi. She is a professor in environmental engineering at Ain Shams University in Egypt. Dr. Shireen, the floor is yours. Please
thank you so much
take
for the
into
time.
consideration that you have only 15 minutes, so we can allow 1 or 2 questions afterwards. The floor is yours.
Thank you so much for the introduction. I hope you can hear me well. I'm very pleased to be contributing to this conference, and especially that it's in Syria. one of my lovely countries, and especially Damascus. So all my greetings to everyone there. I'm Shireen Lagroudi. I'm Professor of Environmental Engineering and the Director of the Solid Waste Management Center of Excellence at Faculty of Engineering, Ain Shams University in Cairo, and we'd be happy to welcome all of you to visit our center. This presentation is also done with my colleague, Engineer Nihad, who would be defending her PhD in the next couple of days. So just to give you a glimpse about Egypt Solid Waste Management Center of Excellence, it's in Faculty of Engineering, Ain Shams University, and we are ISO 17025 certified. And it's a building that's 4-story building, 450 meters square, and we have been.
We seem to have a technical problem again. We can't hear the voice.
Dear Professor Moala, I think the problem is from Egypt now. We hear you very well here in Zoom. Dr. Moala, do you hear me?
Dr. Shireen, our technical staff عم يقولوا إنه المشكلة مو من عندنا، من عندك. Is that true?
دكتور سامعني مظبوط، المشكلة مو من الشام.
عم تسمعينا؟ Can you hear us? نروح اللي بعده.
I will call her.
ماشي.
إذا سامعاني
الدكتور عماد عبد الأحد
رجعت ليك رجعت.
ما أنا موجود. عماد عبد الأحد اسمه موجود.
I'm so sorry. It seems there's something wrong with the internet here in Egypt. Sorry about that. Can you see the presentation again?
Yes. Yes, Doctor.
Sorry about that. So yes, so I'm back. I'm the garbage woman. So we're working in waste management. Of course, this is critical for regional sustainability. Of course, municipal solid waste is influenced by cultural and economic and social factors. And the focus is on sustainable solutions. Egypt's Vision 2030 aims at pollution reduction and holistic waste management. In Egypt, we generate around 27 million tons of waste. Average daily waste generation is 0.75 to 1.25 kilogram per capita. And this is the distribution of the waste generation among different types. With the agricultural waste is the 35%, so it's being the largest contributor to the amount of waste here in Egypt. As you can see, in the different governments, the concentration of organic waste is almost 60 to 70%. That's why this is the major problem here in Egypt, is how to manage organic municipal solid waste in a proper way. This is the situation, unfortunately, for the collection. The collection efficiency is about 35% in rural areas, 40 to 90% in urban areas. 80% of the waste is being open dumped. We have only 9% being composted, 5% being landfilled, and 3% being recycled. As you might have heard that in Egypt, the informal sector or the Zabbalin are really playing a significant role in waste collection and recycling. Besides some private multinational and national companies who collaborate with the municipalities for waste collection and street cleaning. We are working on a project related to organic waste management with Rostock University, Dr. Abdullah Nassour, who is actually present here in this conference, and he's actually Syrian as well, and as well as working on this project with Joe.
يبدو أن المشكلة الفنية اللي عم تواجهنا هذه المرة من خارج يعني سيطرتنا، لذلك سننتقل إلى متحدث آخر، الدكتور عبد الله نصور. عم تسمعنا دكتور عبد الله؟
ايوه عم اسمعك دكتور وائل.
عظيم. دكتور عبد الله نصور استاذ في جامعة روستوك، قسم إدارة النفايات الصلبة، يحمل شهادة جامعية من جامعة تشرين كلية الهندسة الميكانيكية في عام 1985، وشهادة الدكتوراه من جامعة روستوك في ألمانيا عام 1993، وأيضا شهادة دكتوراه دولة من جامعة روستوك عام 2005. من أهم النشاطات هو باحث كبير وناشط في مجال تبادل الخبرات في إدارة النفايات الصلبة. Our next speaker is Dr. Abdullah Nassour. He's an expert in waste management and disposal. Solid waste, I mean when I say waste, solid waste management and disposal. He has a PhD degree from Rostock University in Germany, and his BSc from Tishrin University in mechanical engineering. Dr. Nassour, the floor is yours. You have 15 minutes, and hopefully we will not have any technical issues.
I will try. So, everybody now in the world speak about how we can transfer waste management to circular economy. Thanks really, Dr. Youssef, to spoke about sustainable cities. Yeah, waste management is part of the sustainable cities. I work in this field since many years. Yeah, and I try to use these words. Waste management, circular economy is policy, responsibility, and organization more than technique. It's mean with policy. Yeah, we can organize the money what we need. With policy, we can develop the technologies and so on. When we work about waste management, please not to look only about the technique. Yeah, technique is very expensive. Yeah, please try to work the policy, who is responsible for what, who is for the organization. I work with the most country in the waste in the MENA region. Yeah, and in some cities, when we speak about waste management, we speak about business. Yeah, the main target in waste management is to solve the problem, not to make business. But yeah, we have to speak about cost recovery. Yeah, who should pay the money? Now, in the MENA countries, yeah, about 90% is paid by the government. If we compare to Germany, to Europe, yeah, all the cost paid by the citizen or by the industry. So waste management is several systems. One of the most important of them is the legal framework. So we need legal framework. That's the reason we have Ministry of Environment. But sorry, yeah. So most of the Ministry of Environment in the MENA region play not the role really to develop applicable legal framework. Very important to have legal framework. Financing. Who will pay for waste management? Every day we produce waste. Waste should be collected, should be treatment. Who will pay the waste? I mean, financing is very important. Monitoring, administration, yeah, and the technical system. Users, we, citizens, also informal sectors, yeah, and education. I mean, if we look to the waste management or circular economy, we have to look to all these systems. Maybe some words about Germany, how waste management is developed in Germany. Yeah, that's, yeah, I summarized in 5 milestones. The most important milestone was 1991 by the extended producer responsibility for packaging. It means the producer should pay for the packaging, yeah, and we use this money, yeah, for the waste management. For example, in Germany, only for the packaging, we collect from the packaging about 1.5 billion euro, and we use it for the waste management. That's the reason waste management is working. The second one, yeah, to avoid, it's mean, or to ban the landfilling of waste without treatment, yeah. So, and the third one, yeah, we started separation at source, 1990. But now in each city, the separation at source, it must for the organic, yeah, for the commercial waste too, and so on. It means we need the regulations to develop the waste management. But I will start with the education. That's really my mainly work, yeah, in the MENA, between Germany and the MENA region. Education is the foundation of circular economy. Without education, now we are in the universities in Damascus. Yeah, we did a lot with Syria and education and environment and waste management. So we need skilled personnel for the political institutions or for the administration to develop the regulations, the financing, long-term strategy. When we speak about strategy, we should think about after 50 years. Yeah, it's not enough to think about short-term strategy. Waste management is long-term strategy. Monitoring, international cooperation. This conference today is part of international cooperations. We need skilled personnel for the municipalities. Sorry, the most of the municipalities don't have the skilled personnel to develop this strategy. Yeah, and we need skilled personnel for the industry. Education is very important, and we work together with Ain Shams University and education, yeah, so on. So why the waste management is really in Europe, in Germany is working? Yeah, the municipalities are very strong, and have the money, have the skilled personnel. It's organized. That's the reason why waste management. If we compare really to the municipality in the MENA region, sorry, we have to support our municipality in the MENA region to be strong and to manage this waste management. Municipalities are very important as the end for the waste management. Some figures really from Berlin, city of Berlin has one company only for waste management, only to collect the waste, to treat the waste. Yeah, about 5,500 employees. Yeah, and the turnover for this company is 550 million euro. So, and city like Berlin, 4 million inhabitants, it's not big city. Yeah, and compared to Cairo or other big cities in the world. Yeah, but we have 500,000 bins, and we have to find location for the bins. That's the reason, maybe really some words from the presentation from Dr. Yusuf Diab. Yeah, we have to think from the beginning to find positions, location for these bins. Yeah, so that's one of the most problem what we have in the cities in the main region. We don't have places for the waste bins. That's from my city, 200,000 inhabitants in Rostock. Yeah, we have developed a municipal company. It's belong 100% to the municipality. Yeah. So, and from this municipality, we developed 3 other companies, and one company, 30% is belong to the municipality, and 70% is belong to the private sector. That's really the solution what we need in the main region. Yeah. Financing. Who pay for the waste management? You see here, yeah, we have several bins, but the financing is difficult. Yeah, residual waste and bio-waste is paid by the citizen. Cardboard is paid by the extended producer responsibility. Packaging is paid by the extended producer. My recommendation, yeah, we work a lot in the region, yeah, for Syria. Think about such system, extended producer responsibility. Then we can have some money to support the waste management in Syria. So we can see here packaging electronic waste can be financed by the extended producer responsibility. Tires, battery, hazardous waste, industrial waste. It means we have possibility, but what we need is the regulations. Yeah. If we look to the main region, now we have only 5 to 10% recycling. Yeah, and who's responsible for it? The informal sector. Yeah, 90 to 95% is landfilling. I ask, who is responsible, and what are the solutions for it? So that's maybe some figures from the MENA region. Really, we know the MENA region very well. But again, the challenges what we have. So regulation, that's no pressure for sustainability waste management for the responsible ministries. On all the most of the countries, there's no pressures. Yeah, no practical strategy. Yes, we develop strategy, but this strategy cannot implement it. Landfilling is very cheap. If we compare to Europe, to Germany, yeah, landfilling is very expensive. Yeah, and more expensive than the treatment. That's the reason. It means we are not able to bring the material to the landfill. Financing, no sustainable financing. Government pay about 80% of the costs. No financing system for the treatment. We collect all the waste, but for the treatment, we don't have money. No ABR system in the practice, and so on. It means really, so we have to think about it, and we work together in the regions to develop the sustainable waste management strategy. We look really to support the business and waste management in the MENA region. Why? We will support the private sector. We will support the government. We will plan to create job. Some ideas about business and waste management, waste to energy. Yeah, we have the landfills. Why not to use the landfills to produce energy? That's easy. Yeah. So, or use the landfills area for solar energy. Why not? If we look in Germany, in Europe.
دكتور يوسف
sorry.
ما بقي غير 5 دقائق.
Okay, yes, I will finish.
كأنه بقيان كثير.
Yeah, sure. Yeah. So incineration for big cities, recycling, composting. It's really so that's one project what we do in Bizerta in Tunisia. Some composting project. We need a lot of such composting project in the MENA region. We can create job, we can build technologies, and so on. So that's maybe really that's the solution what we need. Yeah. Here, but that's one project we work together with Ain Shams University and Jordan in Irbid. Yeah. So and we look to support the municipality to establish more companies. That's one project what we do now in Bizerta in Tunisia to support the region of Bizerta to establish more companies. It means we don't look only for the investment. We look to for the organization, and then we go for the implementation. So treatment, yeah, if we look here, the treatment still after 30 years separate collection, still waste to energy is very important. And we have 34 cement industry, and we use the cement industry for waste management. That's very important topic for Syria and for the MENA region. Lot of think about it. Yeah. So if we look maybe, yeah, about the use waste or the RDF refuse derived fuel in the cement industry, we can look with Morocco, Algeria, Tunisia is only 5%. Egypt is 11%. But if we look Austria, yeah, about 80% for the energy what we need in the cement industry is from the waste. Yeah, why not to think about it in the MENA region and in Syria? So everybody speak about the regulations for the emissions. We have emissions, yeah, and my suggestion, let us use the European emissions for the cement industry, and we can solve the problem. That's maybe the role of the ministry. Here, so it was 2021. Yeah, the ministry in Egypt decided 10% from the energy in the cement industry should be from the waste. Yeah. Now the cement industry look it's mean for it. That's from Tunisia now started. It's mean to use the textile in the cement industry. Yeah, we have the regulation, and we have to speak about the financing. We can discuss. But my summary and recommendation: waste management and circular economy is important factor for sustainability and sustainable cities. Not only business, please, not only think about business when you speak up to us. Need in the MENA region for sustainable strategy. Sustainable financing is the foundation of circular economy. Yeah, municipality are the most important elements. Private sector can only support. We cannot give all the responsibility to the private sector. Optimization, the waste collection is essential for the circular economy. Now, also most of the money what we spend in the waste management is only for the collection. Huge demand from composting plant with capacity 500 to 5,000 tons per start with small quantities. Let us do that. Cement industry can play an important role by energy utilization for mixed waste. Need for local production of equipment in cooperation with company from Europe. Thank you so much.
شكرا جزيلا دكتور منصور. رح افتح المجال لسؤال او سؤالين من الحضور. تفضل، ممكن تعرف عن نفسك بالاول.
دكتور شاهين، مدير البحث العلمي بجامعة تشرين. دكتور منصور، circular economy, as you said, depends on 3 principles: environment, economy, and equity. For Syrian situation, I know that you are not far away from our situation in solid waste management in general. So you think that we must go back to composting methods or to biological treatment of solid waste in Syria, or thermal methods? I see that many countries like Germany or Egypt have many legislation in this range. In Syria, Syrian situation, what you are suggesting in this range, please?
Yeah, thank you, Dr. Aysam. So really, incineration is the last steps. My suggestion now for Syria, let us think about the optimization of the collection. 90% of the money, what we paid, is only for the collection. I will compare maybe collection in Europe and in Syria. In some cities in Syria, we collect the bins maybe 2 to 3 times per day. In Germany, yeah, we collect the waste bins 1 time per week. It means let us think about optimizing data collection. That's my the second one. So we need in each small municipalities after from 100,000 inhabitants, one composting plant. Now, by regulation in Germany, we look to do a lot for composting plant. So why? It's very easy, and we can create a lot of jobs. Yeah, and we on our it's mean the soil. It's mean we need compost for our cities. So that's maybe so. But before we go to really to the residual waste, before we go to the incineration, let us think about to use the waste maybe as refuse derived fuel for the cement industry. But for cities like maybe Damascus, yeah, or Homs, yeah, I am to think for waste to energy for the future. Yeah, why not? We are able now to build the waste incineration plant inside city. Like us, look, maybe Dubai. Now, Dubai after so go for the waste to energy. But now we go for composting for other facility. So, but only waste to energy is not enough.
Thank you. Any other comment, Dr. Bassam Al-Aji?
دكتور بسام العجي أستاذ في قسم الهندسة الصحية والبيئة جامعة دمشق كلية الهندسة المدنية. It's not a question. I have just a comment. I think the resolving of solid waste starts with changing our idea about solid waste. It's not material. It's collected material which shouldn't be to collect. About treatment, we don't believe that or don't believe in RDF or gas production from solid waste or incineration in Syria. So thank you for your presentation.
ماشي، شكرا دكتور بسام على هذا التعليق. أعتقد أنه Okay, we will move to our final speaker for the day. لدينا متكلم أخير الدكتور عماد عبد الأحد. هذه المرة سيتكلم من بلغاريا، من صوفيا بلغاريا. حاليا عميد كلية الهندسة المدنية في جامعة الهندسة المعمارية، الهندسة المدنية والمساحة صوفيا بلغاريا، وأستاذ في قسم الخرسانة المسلحة، المنشآت الخرسانية، وعضو في لجنة الكود الأوروبي للزلازل فرع بلغاريا، ورئيس لجنة الكود الأوروبي لتدعيم المباني والمنشآت بالمواد المركبة كمان فرع بلغاريا. Our next and final speaker, hopefully we will not have any technical problem, is from Sofia, Bulgaria. His name is Dr. Imad Abdel Ahad. He is currently the Dean of the Faculty of Civil Engineering, University of Architecture and Civil Engineering, and a professor in concrete structure engineering. And the title of his presentation, as you can see, reinforced concrete bridges deterioration process, a review. So it's a review paper. Thank you very much, Dr. Imad. The floor is yours. رجاء التقيد بالوقت وهو 15 دقيقة دكتور عماد.
شكرا جزيلا لكم. المحاضرة سوف تلقيها طالبة الدكتوراه الموجودة الآن على الشاشة. تفضلي زبادي.
Thank you. Hello everyone. We are very pleased to be here today. My name is Victoria Stoilova and I'm a PhD student, and this is my scientific advisor, Professor Imad Abdul Ahad. Today, I'm going to talk about reinforced concrete bridges deterioration processes, review paper. First, I'll start with a short introduction and some brief literature review, after which a more detailed description of some of the most common deterioration processes will be provided. And finally, we will draw some conclusions. So let's start with a brief introduction. Bridges are a main component of the infrastructure of every country, and their safety and serviceability is crucial for ensuring economic growth. However, bridges are exposed to more unfavorable conditions, and this leads to different types of damage occurring in structural members and makes bridges more susceptible to deterioration and thus to shorter lifespan. There are various processes that can result in disruption of the normal functioning or decrease in the bearing capacity of bridges. In order to recognize the signs that a harmful process has begun in the structure, a substantial and detailed knowledge of the different deterioration processes is required. It is also essential to know what factors contribute to bridge deterioration and to understand how each process works and affects the structural members. So, the purpose of this paper is to provide a detailed review of the most common deterioration processes occurring in reinforced concrete bridges. Furthermore, it focuses on the factors affecting these processes. Finally, an analysis of the possible consequences regarding bridge safety and serviceability is provided. Moving on now, let's turn to the literature review. The problem with the different processes that can cause bridge deterioration is studied by a lot of authors around the world. A summary of the conducted review is shown in the tables. The overall conclusion is that the factors that affect the bridge's conditions and the effect they have on the structural members are similar. Moreover, there are some processes and damage that are found in almost every bridge. Thus, these types of deterioration are the main subject of study in the literature. Based on the conducted research, the most common deterioration processes are identified and will be discussed next. Let's start with one of the most frequently occurring problems in reinforced concrete bridges, concrete carbonation. In general, concrete protects the reinforcement steel from the aggressive environment. On the one hand, it provides a physical barrier between the reinforcement bars and the outside environment. On the other hand, it provides chemical protection. During cement hydration, the strong alkali calcium hydroxide is produced. It determines a highly alkaline environment in which a protective passive oxide layer is formed over the rebar surface. However, as time passes, the protective features of concrete are diminished due to a degradation process known as concrete carbonation. Generally speaking, concrete carbonation can be defined as the chemical reaction between the carbon dioxide in the air and the calcium hydroxide in the cement. As a result, calcium carbonate is produced. Now, let's turn to one of the most common factors affecting the process of carbonation, and that are common for bridges. The first one is the carbon dioxide concentration. In the last 60 years, there has been a significant increase in the amount of carbon dioxide in the atmosphere, about 30%. This increase contributes to faster and more intense carbonation process. Apart from that, bridges have rarely any protective coating, and their surface is in direct contact with the atmospheric carbon dioxide. In addition, the amount of carbon dioxide around bridges is even higher because of the vehicles moving through and under the bridge. Another factor that affects the carbonation progression is the presence of water. It is an important part of the carbonation process as it provides the environment in which the chemical reactions take place. Water exposure is usually due to malfunctioning of the bridge drainage system or damage or overall missing waterproofing of the expansion joints. Other factors affecting the process of carbonation include concrete permeability, the type of cement used in concrete and its content, the presence of cracks, and atmospheric conditions such as temperature and humidity. Now, let's look at the consequences of concrete carbonation. As a result of the carbonation, the amount of calcium hydroxide is reduced, and this leads to decrease in the alkalinity. Thus, concrete no longer protects the reinforcement steel from corrosion. The surface layers of concrete change their microstructure, and favorable conditions for reinforcement steel corrosion are established. Moving on to the next very common deterioration process, reinforcement steel corrosion. It is an electrochemical process which develops in the presence of oxygen and electrolyte. The surface of the rebars comprises of electric cells forming anodes and cathodes. The corrosion process causes oxidation of iron at the anode and reduction of oxygen at the cathode. As a result, a corrosion product or rust is formed. The reinforcement steel corrosion can be divided into two general types: corrosion caused by concrete carbonation and corrosion caused by chlorides, which occurs when chloride ions penetrate concrete microstructure. The second type is localized and more intense. Moreover, once the corrosion process has started, it is very difficult to be terminated, and the damage to the reinforcement bars is almost impossible to fix. Now, let's look at some of the factors affecting the process of corrosion. As it is a direct result of the concrete carbonation, the aforementioned factors that contribute to concrete carbonation also speed up the corrosion process. In addition, the higher concrete permeability and water content makes it easier for aggressive agents to penetrate the concrete microstructure and thus speed up the corrosion. The same applies for higher chloride concentration. Other factors affecting the corrosion include moisture content, temperature, concrete cover depth, and the presence of cracks. Now, let's look at the main consequences of reinforcement steel corrosion: cracking and subsequent spalling of concrete, which in turn leads to reduction of the bearing capacity of the bridge. The product of corrosion or rust may have an increase in volume up to 10 times the initial volume of the steel. Hence, the rust formation leads to considerable internal stresses on the concrete, which eventually result in cracking. As the corrosion process progresses, these cracks widen, interlink with each other, and eventually spalling occurs. Next, I'm going to talk about cracking. Cracks occur in all concrete structures due to concrete low tensile strength. However, there are some favorable conditions for crack formation in bridges. One of the main reasons for concrete cracking in bridges is overloading. On a world scale, there is a constant increase in the traffic flow. This may be a serious problem for existing bridges, especially if these bridges are older, because they were designed to withstand traffic flows corresponding to the traffic flow at the time of design. Furthermore, the increased number of vehicles, and especially the portion of heavy goods vehicles, contributes to faster development of material fatigue. This leads to cracking and eventually sudden structural failure at stress levels that are way lower than the design values. Another very common reason for cracking in concrete is heat exposure. When concrete deformations are restrained, temperature gradient causes additional stresses and eventually occurrence of temperature cracks. Exposure to freeze-thaw cycles is yet another problem that can cause concrete cracking in bridges. When this happens near the surface of the concrete, cracks cause thin cement layers to separate, a process known as scaling, which eventually leads to aggregate exposure. Finally, we have creep and shrinkage, which, if not considered in the design process, lead to additional stresses and strains and eventually to cracking. There are two main consequences of concrete cracking in bridges. First, cracks reduce the element stiffness and thus the deformations are increased, which can have a very negative effect on the bridge serviceability. For example, if the superstructure of the bridge has a big deflection, then the vehicles moving through the bridge cannot reach high speed. The second negative effect of cracking is that the presence
May
of...
I draw your attention? You have only 5 minutes. Okay, please.
Okay. The presence of cracks makes the penetration of water and aggressive agents easier, which promotes the development of the already covered other negative effects. Next, we have delamination and spalling. Delamination is cracking at a plane parallel to the concrete surface near the outermost reinforcement bars. It is a direct consequence of the steel corrosion. If the corrosion process is not terminated and it continues to progress, eventually spalling occurs. Next processes I want to discuss are leaching and efflorescence. Leaching is the process of dissolution of calcium hydroxide salts into the concrete pore water and migration through concrete microstructure. The dissolved salts then crystallize and deposit on the surface of concrete, a phenomenon known as efflorescence. It may occur in the form of white powdery deposit or as stalactite-like formations when water dripping is present. These processes are no serious threat for the bridge's safety, but rather an aesthetic problem. However, they're caused by water migration through concrete microstructure, and their presence could be a sign of other more serious problems related to water infiltration. Finally, I would like to mention the alkali aggregate reaction. This is a type of deterioration caused by the reaction between the alkali hydroxides and some type of aggregates. The most common form is the alkali silica reaction, also known as concrete cancer. As a result of it, a hydrophilic amorphous gel is produced around the aggregate particles. It increases in volume and causes internal stresses on the concrete, leading to cracking with distinctive patterns. To finish today, let's draw some conclusions. To sum up, the negative processes occurring in reinforced concrete bridges, which may cause damage to the structure, are numerous. Moreover, several processes may have the same undesirable effect and thus increase the severity of the damage. The problem with bridge deterioration and damage is complex, and the different processes are connected to each other and cannot be studied separately. On the other hand, these connections mean that the same factors affect more than one deterioration process. Hence, eliminating these factors could possibly stop or at least slow down more than one undesirable process. Therefore, the comprehensive study and understanding of reinforced concrete bridge deterioration processes is crucial for preventing structural failures and ensuring bridge serviceability during its lifespan, and thus creating and maintaining reliable and sustainable structures. Thank you for your attention. I hope you enjoyed my presentation.
Thank you very much for our young lady, our young presenter. I will open the floor for any question or discussion, just for a couple of minutes. We don't have much time. Okay, thank you very much. Thank you very much. Our morning session is over. And we have, I think, according to our schedule, we have 20-minute break, and we shall convene in 1:30 p.m. this afternoon. Thank you very much for your attendance. Sorry for the technical problems, and hope to see you soon. And my colleague, my co-chair, Dr. Samara, he would like to thank you for your patience and endurance with us.
Okay. See you after 30 minutes.
باي عزيزي، إلى اللقاء، شكرا.
تشاو. خلص انت اليوم؟
خلاص. إيه، إلى اللقاء.
شكرا. انا السيشن من عندي ولا كنت تركت؟ Mrs.
يعطيك
Aleva, how are you? Fine. It's
يعطيك العافية دكتور
a
إياد.
great pleasure to see you.
It is really nice to see you, George. I
So
was
finally,
surprised
I
that.
met Dr. Abdel Ahad. You see,
Okay.
since 2018, I heard from you about him, but finally today I met him face to face.
Okay. Yes, I was really happy when I saw that Sergi University is the host of the.